Good afternoon. Today we're going to do grade 11 mathematics paper 1 common sesh June 2019. Question 1. Solve for x in each of the following. When you look at 1.1.1, you'll notice that it's got one term on the left hand side equal to 0, which is what you want, so you can separate the brackets. You'll have x is equal to 0 or 2x minus 5 is equal to 0, 2x is equal to 5, and then lastly, when you divide by 2 on both sides, you'll have x is equal to 5 over 2. Final answers then would be x is equal to 0 or x is equal to 5 over 2. For 1.1.2, which is 2x squared minus x minus 7 equals to 0, it lets you know to get your answer correct to 2 decimal places. Because it says that in bracket, you should think quadratic formula. From the standard form, which is ax squared plus bx plus c, you'll notice that your a value is equal to the coefficient of x squared, which is 2. Your b value is equal to negative 1, and your c value is equal to negative 7. Then you write down your quadratic formula, which is x is equal to negative b plus minus square root b squared minus 4ac over 2a. From there, I substitute the values. I'll have negative, in brackets, negative 1 plus minus square root negative 1 squared minus 4 times 2 times negative 7 over 2 times 2. Then if you use your calculator and you round it off, you'll get the following answers. X is equal to 2,14 or x is equal to negative 1,64. For 1.1.3, we're working with an equation in a surd. We have x minus square root 2x minus 1 equals to 2. So our first step would be to get the surd alone. If I take over the x, it's going to become a negative. So I'm going to have negative square root 2x minus 1 is equal to 2 minus x. From here, I'm going to divide by a negative, so I can have my positive square root 2x minus 1 equals to negative 2 plus x. Then I want to get rid of the square, so the square root, so I'm going to square on the left hand side and square on the right hand side. So I'm left with 2x minus 1 is equal to, when I expand the right hand side, please remember that brackets becomes a trinomial. So I'm going to use this short method. Negative 2 times negative 2 gives me 4. Negative 2 times x gives me negative 2x times 2 gives me negative 4x. X times x is x squared. Because this is a quadratic equation, I'm going to get everything onto one side. So I'm left with x squared minus 4x plus 4 minus 2x plus 1 equals 0. From here, I'm going to use like terms, so it will be negative 6x plus 5 equals 0. If you factorize the following, you'll have your factors of 5 being 1 and 5. Then you have your x and your x. Because of the plus, your signs needs to be the same. Because your middle term is a negative, each of them are going to get a negative. So x is equal to 1 or x is equal to 5. And then because it's a surd, you have to check if 1 and 5 is applicable. In this case, 1 is not applicable, but 5 is. For 1.1.4, we have an inequality, 3x squared plus 7x minus 6. When you factorize this trinomial, you'll notice it is a complicated trinomial. So on the right-hand side, you don't have to show this step, but I'm going to show you how I work out a complicated trinomial. I take the 3 and I times it by 6. That will give me 18. From here, I'm going to get factors of 18 that if I subtract them will give me 7. So in this case, it would have been 9 and 2. And then I have to replace 7x with these two values. So it's going to have to be plus 9x minus 2x to get my positive 7x. So I'm working with 3x squared plus 9x minus 2x minus 6. Then I'm going to do grouping. 3x, take out, it will get x plus 3. Close the bracket. Then I'm going to take out a negative 2 so I can have an x plus 3 in the second bracket as well. Then I'm going to take out the bracket x plus 3, so I'm left with 3x minus 2. And that will be my factors. 3x minus 2. From here I have my critical values, that being x is equal to negative 3 or x is equal to 2 over 3. If I were to draw a sketch to see how my notation is going to look like, it's going to be negative 3 over here and 2 over 3 over here. So this parabola basically is telling you that in the middle of the two, it's negative values, and off to the side, you will have your positive values. And because this inequality talks about greater than and equal to 0, I want the positive values. So finally, my x needs to be less than but equal to negative 3, or x greater than but equal to 2 over 3. For 1.1.5, again you have an inequality, but luckily it's already factorized. So you're going to have your 3 to the power of x. It has to be greater than 0 for it to be possible. And then you can work with your x being less than negative 1/3. 1.2, solve simultaneously for x and y. Here I'm going to take the linear equation and get the variable x alone. So I'll have x is equal to 5 plus 4y. Then I'm going to substitute everywhere c and x, 5 plus 4y. So I have 5 plus 4y squared minus 2y times 5 plus 4y minus 3y squared equals 0. Then I'm going to expand the brackets. I'm going to have 25. 5 times 4 is 20. 20 times 2 is plus 40y. And then 4y times 4y is plus 16y squared. Minus 2y times 5 is negative 10y. Minus 2y times 4y is negative 8y squared. Minus 3y squared equals 0. If I add up the like terms, I'm going to have 5y squared plus 30y plus 25 equals 0. I can take out a common factor of 5, so I can have y squared plus 6y plus 5 equals 0. Then I'm going to factorize. The factors of 5 is 1 and 5. Y. Because of the plus, the signs need to be the same. Because the middle term is plus, both of them gets a plus. So I'm going to have y is equal to negative 1 or y is equal to negative 5. From here, I'm going to take those values and I'm going to plug it in to that equation to get the x value. So for the first one, it would be x is equal to 5 plus 4 times negative 1, or x is equal to 5 plus 4 times negative 5. So the first answer would be x is equal to 1, or x is equal to negative 15. And that is the end of question 1.